Hello everyone, welcome to Code Hub. Consistency is the key to success. Let us solve today's LeetCode daily challenge. The question is maximum points you can obtain from cards, and the question states that there are several cards arranged in a row and each card has an associated number of points. The points are given in the integer array card points. In one step you can take one card from the beginning or from the end of the row. You have to take exactly k cards. Your score is the sum of points of the cards you have taken, and given the integer array card points and the integer k, the return the maximum score you can obtain. So this is the example one. Here we can take from the first we can take this card, and then from the last we can take this card, and then from the first again we can take this card, and total we have taken 3 cards and their score is 2 plus 1 which is 4. And we can take another combination. We can take last 3 cards, then the total sum is total points is 12. So we have to maximize such cards to take k such cards. We have to maximize the score. So this is the overall problem statement. Hope you understand. We can take this example once again and see what we can observe here. Either we can take this one and then this 2 and then this 3. These are the first 3 cards. This is one possible combination, one possible way. One possible way is 1 plus 2 plus 3. Second possible way, next possible way is we can take these 2 cards and we can take at finally the last card, 1 plus 1 plus 2. Another possible way is we can take this first card. So another possible way is, so we can take this from first we can take this one, and then from last we can take these 2 elements. So that is 1 plus 1 plus 6. And another possible solution is we can take at last 3 elements itself, 1 plus 6 plus 5. So in this we get 12, in this way we get 8, and in this way we get 4, and in this way we get 6. So in this the maximum possible answer is 12, so we have to return this. So this is the problem. For this what we can do is we can go for a recursive solution, since we are trying for all possible ways. So I will write the recursive solution, then we will try to convert to DP, and let's see whether it is getting accepted or not. The constraints are 10 power 5 and the length is 10 power 5. So okay, let us go for a recursive solution. I will write a function which is going to give me the maximum points. The function is solve, and I will pass the parameters as card points. I will get the size of the array first. Card points dot size, and I will pass the parameters as 0 and n minus 1, because whether I can take the first element or I can take the last element. So I have to pass 2 parameters, the first and the last index, and I have to pass k also, and I will define the function int solve vector int, with reference I will pass. I will name this as start and this as end, and this is k. And what are the base cases? If k is 0, then I can return 0. I don't want to add any elements to my maximum score. Another one possible case is L can reach, the start can pass through the end. So if my start is equal to my end, I can return the card points of start or end. Any other index I can return. Or else I have 2 options where I can take this first element and then I can move on to the next. That is, I will take card points of start, and then I will go for a recursive call of card points start plus 1 end and k. I'm taking one card, so I want to decrease the k to 1, k minus 1. And another option is I will take card points of n, the last element, and then I will move on to the recursive call, which is defined as start end minus 1, k minus 1. So this is the recursive solution for this problem. Hope this makes sense. We can just run the code and see it. Okay, it is caught points, sorry. We'll just run the code now. It gets accepted. We will use the example test cases. Since the card length is 10 power 5, if we click on submit, it will not get submitted since it will give time limit exceeded. Okay, it gets time limit exceeded for this small test case itself. We can run this in our console and see once. 1 second. Oh, we can convert. Meanwhile, we will convert it to DP solution. Since the changing parameters in this recursive call is start, end, and k. For this small test case itself, it gets 27. The runtime is 2759 millisecond. So let us see whether we can reduce it once we convert into a DP solution. Vector of int. Since three parameters are changing in the function, we will declare a three-dimensional array. Vector of int, which is of n, vector of int. Sorry, n, vector of int, n, vector of int, k, minus 1. This. So we have declared the three-dimensional array, and we will pass the DP into our recursive solution. DP, and we will pass in this recursive call as well, and we have to cache this solution DP of start, end, and k, and we will be using k plus 1 since it should not affect while caching. If it is all, the sub problem is already seen. DP of start, end, and k is not equal to minus 1, then we can just return DP of start, end, and k. We got 25759 millisecond. We can run the same test case and see whether it is getting minimized. Yeah, the runtime is a lot reduced since we are not recomputing the sub problems, since we have used DP. We will submit the code again, but here it won't get accepted since it will get memory limit exceeded, because 10 power 5 we are using three-dimensional space. Here the k also goes till the card length, so it becomes 10 power 5 into 10 power 5 into 10 power 5, so it will show memory limit exceeded. So let us optimize this approach. Here the solution is n cube. Okay, this is our recursive solution. Hope you got some understanding in recursive and DP. Let us see in some other possible way we can approach this problem. 1, 2, 3, 4, 5, 6, and 1. This is our given array. What we are doing is we can take these three cards, or else these two cards and this one, or else this one card and this two, or else these three cards itself. So basically what we are doing is we can go in reverse order and see. We can just take these three cards finally, or else we can take these two cards and this one card, or else we can take this one card and these two cards from front, or else we can take from these three cards. So what we can observe here is if we get the overall sum from this n minus k. This is the, I will give the index 0 1 2 3 4 5 6, and from this n minus k, n is 7, 7 minus k, k is 3. From starting from n minus k, we will compute the total sum, and we will store it in our current maximum sum itself, and we can traverse from n minus k till the end of the array. What we will do is we will eliminate this 5 and we will add this 1 to our current sum, and then we will eliminate this 6 and add this 2 or to our current sum, and we will eliminate this 1 and add to this 3 to our current sum. Then what we are getting is we will get all the possible ways, starting all the possible ways by taking the k cards. So I will give a dry run. We will take these 3 cards, which is 5 plus 6 plus 1. So our current maximum total sum is 12. Then what we are doing is we will eliminate this 5, 12 minus 5, and then we will add this 1 to our answer, to our current sum. So what we are doing is 6 plus 1, 7 we are having, 7 plus 1, which is 8. We'll add this 1, so we will get the 8. Now from this current sum 8, we will eliminate this 6, and then we'll add this 2. So what we are doing is we will add this 1 and we will add this 1 and 2. So we have 3 cards. So 8 minus 6 plus 2. So what is the sum? It is 4. And again we will eliminate this 1 and add this 3. So what we are doing is 4 minus 1 plus 3, which is 6. So from what we are we have achieved all these possible ways by just computing the current sum and updating our maximum sum. So we can do this we can do this problem in order of n solution itself. For this, what we are doing is we will have the size of the array. We will get the size of the array first. What we are doing is we will have a current sum, namely current sum, which is 0. We are starting from I to I, we are starting the I from n minus k till n minus k till I is less than n, I plus plus. We will just add the to our current sum, chord points of I. Next we will have the maximum points, which is our answer, which is the current sum. We will just return max points. Next what we are doing is, again we are starting the loop from this n minus k till n. Next what we are doing is we are just decrementing our current sum with chord points of I. Then we are we are adding the current sum with the first index, and then the next index, and then the next index. So we will have a pointer which is the start, which starts from 0, and we will increment the start from in our loop itself. We'll just add the chord points of start to our current sum. Then we will update our max points, which is max points is max of max points comma current sum. And finally we will return the answer. We will just run the code and see. We get wrong answer. Let us observe what is the wrong in it. Here I didn't add the current sum, sorry. Here it is current sum plus equal to chord points of I. We will just run the code now. It gets accepted, and here the runtime is even reduced to 0 millisecond. So here the time complexity for the solution is order of n, and our space complexity for this solution is order of 1. We have not used any extra space. We will submit this solution now. Superb, it got accepted. Let us see in tomorrow's daily challenge. Until then, bye.